What's up, YouTube people? In this video we will prove that this function satisfies the inner product properties. Before showing this, let's remember the properties of the trace. First, the trace of the product A and B times B is equal to the trace of B and A. The second property is that adjoint of T times T is positive. The third property is the trace of the sum A plus B is equals to trace of A plus trace of B. The fourth property is the trace of scalar Z times T is equal to the scalar leaves in the of the trace of T. And the fifth property is that adjoint of S times T, okay, is equals to the adjoint of T times adjoint of S. And the sixth property is the trace of T adjoint is equals to the trace of T, and all this with conjugate. Perfect. With these properties I will use for prove this statement. Then proof. Let's start with the proof. First property, the positivity. Nice. And then let the T inner product T of T is equals to, by definition, the trace of T times T adjoint. Nice. And with the property 1, T and T adjoint, and so this first property, T adjoint times T is equals to 3. And then the second property, adjoint of T times T is positive, so this trace is positive by the second property. Okay, so this inner product is positive. Okay, the second property to the proof is definiteness. Then suppose the inner product of T and T is equal to 0. In other words, the trace by definition of T times T adjoint is equal to 0. The first property, this trace is the trace of T adjoint times T equals 0. So let the set of vectors E sub 1, E sub 2, E sub 3, E sub n be basis of vector space B, and then the inner product of T adjoint times T of E sub 1 and E sub 1 plus the 2, the 3, and to the T adjoint times T of A sub n and E sub n, then equals 0. So by the definition of adjoint T of T, the inner product of T of E sub 2, E sub 1 and T of E sub 1 plus to the inner product of T of E sub n and T of E sub n is equals to 0, which is equivalent to, by definition of inner product, the norm of T of E sub 1 to x square plus plus the norm of T of E sub n to x square equals 0. And the conclusion is that implies that T of A sub j equals 0 for all j in the 1 to 2 and t and so n. Therefore T is equals 0. Okay, the third property to prove is the additivity in first slot. Okay, and then the inner product to the S sub 1 plus S sub 2 and T is equal to, by definition, the trace of the matrix S sub 1 plus S sub 2 times the joint of T. And by the distributivity by the product right, this is equal to the trace of S sub 1 plus T adjoint plus S sub 2 times T adjoint, and this by the property of sum of trace. This property, this here, by the way, this is a trace separating the sum of S sub 1 times T adjoint. This displays trace of S sub 2 times T adjoint, and inner product by definition is equals to the inner product of S sub 1 and T, and this by definition of the problem is the inner product of S sub 2 and T. Okay, the fourth property is the homogeneity in first slot, and for to prove this property, let the inner product of lambda times S and T. This is equals to, by the definition, is a trace of lambda times S and times T adjoint. By the property of the trace, the scalar leaves of the trace. By this property, the scalar leaves of trace. Then so this is equals to the trace. This is equals to the lambda times the trace of S times T adjoint. And by definition, this is the inner product of S and T. Okay, and finally, I approve to the conjugate symmetry. Okay, take the inner product of T and S and T. This is equal to, by definition of the trace of S times adjoint of T, and the property of adjoint. This is equal to trace of, this is equals to the T and S adjoint reverses the order of the products and affect path of the adjoint, and this is equals to the conjugate of the trace of the T and S adjoint, and this is equals to, by definition, of the inner product of T and S, and all this with the conjugate. Okay, and with these 5 properties, we will conclude that this inner product satisfies all properties of inner product. Also, this inner product is very famous. This inner product is also called the Frobenius Inner product, and take by definition of extent of the matrix also. This is equals also the trace of A times B adjoint.